Okay, so for the next module, we want to actually look at some hands-on demonstration. I've been promising this to you for about 12 modules now. We're finally getting to it. We're going to start out on our switch. I've got here just a 3560-24. It's actually a PoE switch. If I do show power in line, and before I actually do anything, I'll warn you, I use the same switch for my voice classes. So I've got a lot of IP phones on here taking power. We'll see the information show up through CDP. So pay no attention to that. We're not really going to be using them for this class. We will be using a portion, well, really not the wired IP phones, but a few of my 9971 wireless and 7925 or 26 wireless IP phones for the CCNP wireless portion deploying voice networks class. At any rate, so you see that I have a number of, if I do a show power in line, I have a number of IEEE powered devices. These are some older IP phones, some 7961s. Here I have some newer 9971s. We see the maximum of 15.4 watts that can be used or pulled. And we can see that some of my phones are at 7, some are at 12.8. But we also see that I have some things like an Aeronet, CapWAP 3502 access point, Aeronet lightweight access point, 1262N. Those are both pulling the max of 15.4. I've got a 1242 pulling 15.0. 1252 pulling 15.4, and an 1131 pulling 12.2. We can also see what port those happen to be on. Okay, so we can see that we've got PoE and it's providing power to, I've got 5 access points here. Okay, if I do a show CDP neighbor, I can also see that I've got a number of these APs, and I've actually gone ahead and named some of these APs, such as sales support floor 1 AP2, sales support on floor 1 AP1, sales support floor 1 AP3, sales support floor 2 AP2, and it doesn't look like sales support floor 2 AP1 is showing up currently. I also have, and by the way, it shows what the platform is. So the platform is a Aeronet lightweight access point 12 series, 12 series, 11 series, and my 3500 series. Okay, we can see what port those are attached to. We can, and in fact, those happen to be plugged in directly. No. So I actually have my wireless LAN controller is actually plugged in. I have 2 separate ports. So on the wireless LAN controller, they're labeled Fast Ethernet 001 and 002. So that's the remote port ID. And then the local interface, they're plugged into Fast Ethernet 010 and Fast Ethernet 020. So if I do show run interface, Fast Ethernet 010 and Fast Ethernet 020, I can see that one of these ports I'm using as an access port, switch port mode access. And this is kind of a little bit of a refresher, or at least it should be, to your CCNA general or CCNA route switch would be more apropos. Course that you should have either taken or at least had the understanding of before coming into this class. You don't necessarily have to have taken the exam, although if you do want your CCNA wireless exam to be taken and actually count towards the certification of CCNA wireless, then you do have to have taken CCNA route switch or just CCNA general, the same thing pretty much, before having taken, or I should say at least in conjunction with having taken the CCNA wireless. You could possibly take the CCNA wireless exam, not be certified in anything, then go take CCNA route switch, and then be certified immediately in both route switch and wireless. Could do it in the reverse order. So at any rate, a little bit of a refresher, going over kind of soup to nuts from the beginning to the end. Switch port mode access. Whoops, sorry for the scroll. My mouse kind of a little sensitive. I've got spanning tree port fast, so if we're remembering spanning tree is just something that prevents layer 2 loops. I've set it to the port fast mode, so it's basically, it's a little dangerous, but it's basically telling the switch there's nothing on the other side that could cause a layer 2 loop, so just come up very quickly. Don't necessarily go through the whole blocking, learning, listening, forwarding phase. Switch port mode access, we're in an access port, and the particular VLAN that all traffic should come in and be placed into here is VLAN 200. We'll take a look at the VLANs or virtual LANs here in just a moment in the VLAN database. So on this Fast Ethernet 010, which if we go scroll back up and take a look at our WLC on this local Fast 010, it's port 1, okay, 001, is the WLC, the wireless LAN controller, is it sending me traffic over this port in a 802.1q fashion? No, because I have switch port mode access. So it's sending me just raw Ethernet headers, okay, an Ethernet frame. And I'm taking all that data and I'm putting it into VLAN 200. The switch is intelligently doing that. Now, all the traffic, if I scroll back up again, the wireless LAN controller that's attached to my local switch port 0/20, it's remote WLC port 2, Fast Ethernet 002. Here on my local port 20, is it sending me 802.1q headers? Yes, because the switch port mode is trunk, and specifically for a switch port trunk mode, I've chosen the encapsulation of .1q over other encapsulations like ISL. So .1q being the industry standard, 802.1q is what that .1q stands for, as we mentioned previously. So if I were to go into interface Fast Ethernet 0/20, I could also say something like switch port trunk VLAN, switch port trunk allowed VLANs. And I could say that only certain VLANs were allowed to be here. So I could say something like VLAN 1, 200, 210, 10, and 20. A little bit out of order. But let's do show run interface Fast 020. And now I am adding a layer of security and saying that, yes, while this is a trunk port, it's not in a mode to negotiate or be dynamic, which are other options, but it is hard-coded as a trunk port, specifically supporting the 802.1q encapsulation header type. The VLAN ID in that header must be either 1 or 10 or 20 or 200 or 210. And so if I go ahead and do show VLAN brief, I'm going to see that I have a lot of other VLANs here because I use this for my voice VLAN. I've got VLAN 2111, 2112, 2122, okay, 2522. I've got a lot of other VLANs. But I do have, if I scroll back up to the top, I have my VLAN 1, which is the default VLAN. I have VLAN 10, which I've already created and named sales. And we'll go back over that process just so that you're familiar with it in case you don't know how to do it. I have VLAN 20, which is support. I have two other VLANs that I use for this particular switch when I use it when I travel and teach classes that I don't want to allow on that particular or to traverse that particular trunk, 101 and 102. I have VLAN 200 where I have my wireless WCS server, WLC, and APs. Maybe I have separate, and we're going to take a look at placing these access points in separate VLANs 210 and 211. I thought it was 210 and 220. So let's go back and change that instead of, what was 200? Was 200 anything? Yes. So instead of 200 and 210, I actually want to add one more there. So let's go config T, interface Fast Ethernet 020, and switch port trunk allowed add, not VLAN add. So I want to instead of just having to retype out that entire thing, I just want to add VLAN 211. Okay, so I added VLAN 211 to that. Okay, so again, on my second port, I have a trunk, and I'm allowing a number of different VLANs. On my first port, I'm using it pretty much for management only, VLAN 200. I could have more ports. I have up to 4 ports on this particular box. So I could, or actually, sorry, on this particular box I have 8 ports. So I could actually add additional ports. Now this is a 2100 series controller, a 2106, and that 6 actually determines the number of APs, or is in reference to the number of APs that this particular controller can handle. But so it does have a few limitations in the feature set that I can do. One of the things we'll talk about in reference to mobility, but really won't be too much in terms of limitation. We'll still be able to do clean air and some other things. So, or at least some clean air monitoring. Okay, so let's take a look at our ports for our APs. Actually, before we do that, let's go ahead and talk about how to create VLANs. It's very difficult to do. Config T, VLAN, and then the number. So VLAN 200. Do show VLAN brief. So 200 already has a name of wireless WCS and WLC. Let's go ahead and just say we're in the VLAN 200 already. Let's say name wireless WCS and WLC only. Okay? If I do show VLAN brief again, it's still named this, and it will still be named this, and actually nothing applies until I exit out of that particular VLAN. Now it's changed its name. But that's as hard as it is. Create VLAN space 210, give it a name. AP, some APs. Exit. VLAN, and I don't necessarily have to hit exit on every one, just changing to another configuration, like just saying VLAN 211 would also apply it. More APs. Sorry. Name. More APs. So that's as difficult as it is to create and name VLANs. So now let's go back and do show CDP neighbor again. And let's take a look at some of the ports that I have. So let's take a look at port 11, 12. It looks like 13 might be, actually, let me just take a look here because I'm missing 13 and 15. Let me see where my 5th AP is plugged in. Okay, it looks like 13 is vacant, but there is actually something in 15. And show power inline, I think, would have told me that, yes, 13 is vacant, but 15 actually has a 1242 that's just not being used right now. In fact, I think that has an autonomous image on it right now, and that's the problem. Okay, so let's do show run interface fast 011. And I can see that this is in access mode. Its VLAN is 200. Now you might say, well, wait a minute, Mark. We were talking about bridging wireless LANs or SSIDs to their VLANs. And we did that, or we were about to look at that in the actual graphical user interface of the WLC. But we talked about it in the slides in the concept of doing something called dynamic interfaces on the wireless LAN controller. If we're wanting to bridge traffic from, let's say I have multiple SSIDs, and by the way, show VLAN brief, if you didn't figure out, we're going to create a VLAN for sales and support, and maybe we'll even, let's go ahead and create a very specific VLAN 5 and name it guest, rather than just using the... And yes, I realize I'll need to go back to my interface fast 020 and switch port trunk VLAN, switch port trunk allow VLAN add 5. so that I have that VLAN in there as well. But we're going to create an SSID of sales, of support, and guest. And if I want to map those to the particular VLANs, that means that in order to have multiple traffic come across and be sent to those particular VLANs, I have to have a trunk link, right? So if I have to have a trunk link, then this AP, this 3502 AP on Fast Ethernet 0/11, it doesn't have a trunk link. It's an access mode. So how's that going to work? It's not going to work, right? It is going to work for this reason. And let me just actually draw this out so that everyone's very clear on this point. It's an important point. I have my AP with 3 antennas. Maybe it's got 6 antennas because it's a dual radio. Okay? It has an Ethernet link. The Ethernet link is to a switch. Let's call this switch 1. Okay, so here's the port that this is linked to. Then I have, let's say, coming off of another port is a link to a server. And then coming off of another port is an Ethernet link to my wireless LAN controller. Okay, so I've got my link here. Now, emanating out from this AP is the SSID of sales. And that's going to be ultimately mapped to the VLAN 10. The VLAN 10 happens to be named sales, but really the naming has no significance. It's just there for our sanity. Okay, so the SSID of sales will be mapped to VLAN 10. We're going to have another SSID, and in this case, I'm not saying that these multiple colors are different channels. These are different SSIDs. I'm not going to put the SSID of guest, even though we'll have that one as well. But I'm going to have the SSID of support. And that's going to be mapped. Really, it's a two-way mapping because traffic doesn't only flow from wireless to wired, it flows from wired back to wireless as well. So this two-way mapping is going to be to the VLAN of 20. Okay? So the VLAN 10 and 20 are mapped to sales and support respectively. So doesn't that mean that I'm going to need to make this port a trunk port so that those multiple SSIDs, which are being changed in the AP, can be bridged across to their proper VLAN? And I kind of wish I hadn't drawn that because I need to erase it now. You know what? I can do it without erasing it. The answer is no. This does not need to be a trunk port. This can be an access port. I'm just going to fill this all in with black. Whoops. To illustrate that this is just a standard access port. Now the reason for that, I'm going to use orange as a trunk port. The reason for that is that the wireless LAN controller, first of all, it has multiple interfaces, but the wireless LAN controller is going to have a trunk port. It is going to be able to send multiple VLANs across into the switch to VLAN 10 and to VLAN 20, which reside in the switch. And I don't know, maybe the server happens to be a part of VLAN 20. It's a support server or something. Okay. So how does the traffic get from the AP? Well, remember that we are encapsulating everything in a CAPWAP, or again, LWAP was the older fashion. And in fact, someone brought up a good point during a break that the 640-722 blueprint still refers to everything as LWAP, and it actually refers to things like HREAP, H-REP, hybrid REAP for remote access APs, or remote office, remote edge, Office Extend APs, rather than the new terminology of FlexConnect. Again, it's really not that big of a deal. FlexConnect is just a new branding. It has a few new features, but it has pretty much, it's just a new branding of the old HREAP. And CAPWAP, while it has a number of new features, we outlined those very specifically in one of the slides. And I'll bring it back up at some point here. But the differences in UDP port, the differences in the fact that not only the management and control frames are encrypted, but also the data is encrypted as well. So the differences we've already outlined, and it is probably going to be important that you understand both. So anytime I say CAPWAP, think LWAP is essentially synonymous with it. Yes, it's an older version of it. Yes, it has a different port number, 12222 and 12223 versus 5246 and 5247 for the newer CAPWAP. Okay, but other than that, it shares 98% of the same similarities or of the same characteristics. Okay, so whenever I talk about a CAPWAP tunnel, I'm talking about an LWAP tunnel if you want to think of it that way. It's important that you understand for today's networks, CAPWAP and the newer ports, Cisco could test you on either one. They may even test you on the differences. By the way, just because they don't necessarily have the actual protocol name or acronym of CAPWAP on there doesn't mean that they can't necessarily test you about it. Okay, LWAP really, in today's environment, that really does cover that as well. So anyway, everything is going to be encrypted on a single communication line back to the WLC. So it really is coming across an access port here in the switch. And that's what we got off on this very important tangent about, is that should this particular port here, where the access point is connected into the switch, should it be an access port or a trunk port? It can be an access port. In fact, it probably should be an access port. By the way, even if you configure something as a trunk port, provided that you have something called a native VLAN, the native VLAN is something that is untagged. Basically, all Ethernet headers, all Ethernet frames that come from a given device into the switch will be placed into the native VLAN. So as long as the native VLAN is the same as what you want your access VLAN to be, it would still function properly. Actually, the only difference would be, that it would accept trunk headers as well. You just may not be sending them. Okay, it should function as well. Essentially, this needs to be an access port, and you will send all that data encrypted through CAPWAP or LWAP, whichever you want to call it, over to the WLC, and then, as I mentioned, the WLC will have the trunk port into the switch, and it will send and do the frame bridging, the frame translation, and the frame bridging from 802.11 to 802.3 and back. Okay? So let's go back to the switch. So I am going to have this in access mode. And I'm going to go ahead and change this particular AP, let's say, to VLAN. Let's say to VLAN 210. Okay, so do show, let's say, power in line. That was my 3500 on fast 011. Do show VLAN brief. I put that in VLAN 210. Let's go ahead and put interface 12 into VLAN 211. And then let's go ahead and take a look at, first of all, to make sure that we have, we're going to need to have a layer 3 interface. We could probably bridge this switch across to a router and do what's called router on a stick routing, but we're just going to do everything here in this very highly capable, highly intelligent layer 2, layer 3, actually layer 4 switch. So let's go ahead and again show VLAN brief. We've got VLAN 200, 210, and 211, and we're also going to have VLAN 5, 10, and 20 that we're going to use. So let's go ahead and create, or actually let's do a show because I already have some of these. Show run pipe 2, begin. If you're not familiar with the pipe, it's an output modifier, and it will greatly reduce your headache of seeing all of your configuration. I highly recommend getting used to using it because once you start, you won't stop. And we can pipe to an output modifier of include or the entire section of. Let's do a section of interface VLAN. And that's right, the switches don't support section, at least not this particular iOS. So let's begin with interface VLAN. So I've got interface VLAN 1, which this is called my SVI, my switched virtual interface. It's my layer 3 interface corresponding to a layer 2 VLAN. So here I've got VLAN 10, VLAN 20. We don't really care about 101 and 102. We're not using them in this class. And then I've got VLAN 200, 210, and 211. Okay, so let's go ahead, and I've already assigned IP addresses. I've got an IP scheme set up. We can see that for VLAN 10, the IP scheme is 10.10.0/24. This particular IP address is 10.10.1 with a /24 or 255.255.255.0 subnet mask. The 10.20.20.0/24 subnet for VLAN 200, 10.1.1.0/24 just happens to be IP address 1, host 1. And I'm going to go ahead and set up interface VLAN 5, and you'll see this come up now because I just now created it for the first time, so it changed state to up. And we're going to name this fairly similarly, or I should say give it an IP address that's scheme that's very similar. So let's say 10.5.5.0/24 with this particular interface being the .1 host. And so if I do show IP interface brief, pipe to exclude unassigned, I'll see only my interfaces that have IP addresses that are assigned. And so I can see, I can see my SVIs, my switch virtual interfaces that have, that I'm using for this particular environment. VLAN 102 you can ignore. Okay, that's used for voice stuff. But VLAN 5, 10, and 20 are guest, sales, and support. VLAN 200 is basically management. VLAN 210 and 11 are different APs. So now let's go back and do that show run begin interface V again. I've got my VLAN 5, 10, and 20. Those are where my clients, my actual wireless clients are going to be. Here's where my wireless servers are going to be and my WILSI. And here's where my APs are going to be. Now you can see that I have an IP helper address assigned here to interface VLAN 210. I'm going to assign that same IP helper address to VLAN 211, where other APs are going to be. So let's just do that real quick. I'm going to assign IP helper address 10.1.1.21. So I'm pointing the 10.1.10 and the 10.1.11 subnet. Anyone that broadcasts certain UDP ports, I'm going to point those over to the VLAN 200 10.1.1 subnet, and specifically to the 10.1.1.21 host. The .21 is actually my wireless LAN controller. Now, which UDP ports am I broadcasting? Is it show IP helper, show IP forward protocol? No, it's not going to show it that way. All right. Show run pipe to include forward. So other than the defaults, which include bootp or DHCP, I have added IP forward protocol UDP port 5246, which is CAPWAP. Again, for LWAP, it would be 12222 or 12222. Okay? If in doubt, you could just do both. And just in case you happen to have or were concerned about having older APs on your network, you could forward 12222 as well. So how am I going to, now that I have my layer 3 subnet set up, clearly, how am I going to make sure that everyone gets IP addresses? Well, some of the people like the wireless LAN controller and the WCS server, I'm going to statically assign. And maybe I even want my wireless LAN controllers to get them through DHCP. That's certainly an option. But all of my hundreds and thousands, or in this case 5 or 4 that are in lightweight mode, APs, I want them to get DHCP. Now you might be thinking, well, wait a minute, in a traditional IT environment, I want all my servers to be statically IP addressed because that's very important that everyone talks to the same IP consistently. Well, yes, for the most part, that's true. DNS does offload that somewhat, that we can talk to or resolve, ask for a host name and resolve an IP address. But still, I get what you're thinking. But APs, who really needs to talk to the AP? Think about it. Nobody talks to the APs. Well, the clients do, but they actually talk to the MAC address of the APs. They're on the layer 2 wireless domain, so they're broadcasting or either broadcasting or transmitting to the BSSID or the MBSSID, which is the MAC address of the particular AP, or if it has multiple wireless LANs, the hash-derived value of the wireless LAN MAC address, wireless LAN specific or SSID specific MAC address. So they're talking layer 2. They're not talking to the layer 3 IP address of the AP. The clients, the laptops, the PDAs, the smartphones, they don't care about the IP address of the AP. So who does? Well, the WLC, the wireless LAN controller, does, and the WCS. Does the wireless LAN controller ever go out and talk to the AP? Only once the AP has initiated that discussion. Again, taking it back to a voice analogy, we never statically define IP addresses on the actual IP phones. That would be an administrative nightmare. Because the phones, no one ever talks to them. They talk to a central server. Same thing with the APs. They talk to the wireless LAN controller. Once they've associated, then the wireless LAN controller knows who they are. So what if an AP changes an IP address? Well, then it just talks to, during a next update or during a reassociation or possibly a deassociation and then a new association, it talks to the WLC again and it says, hey, here I am. It notices that the MAC address is the same, and that's really what it cares about, the root or burned in BSSID. And the IP address has changed. So what? So I contacted on a new IP. Really doesn't matter too much. So we want to make sure that our APs are being assigned DHCP given IP addresses or dynamic host IPs. It's very possible that you might want your WLCs to be that way as well. Probably you'll want your wireless LAN controllers to be static, but that's up to you. Once you have the wireless control system, that will be a newer centralized management point. But we do still have to add the wireless LAN controllers to the WCS. They don't necessarily do the same kind of auto discovery that the APs do to the wireless LAN controller. So at any rate, we're going to need to look at some DHCP. So let's do show run pipe 2 section DH. I don't have section. Fine. Begin DHCP. So I've already set up a few DHCP pools. One for the WLC, just in case we need it. I've got one on the AP pool. Let me just, okay, I've actually got one for sales and support and one for, in fact, I should probably add, let me just add comments in here or descriptions. Oh, older version of code. All right, that's fine. So we won't add a description right now, but the 10.1.10.0 was the VLAN 210. We're also going to add one for VLAN 211. Okay, so we're basically going to take and say this is this was APs. We're going to take that. I'm going to open just a quick text editor, and I'm just going to modify this and say, let's say AP2, APs 2. This is .20. Default router is .20. DNS server, whatever, that's fine. Because I'm sorry, it's .11, not .20. Okay, so network 10.1.11, default router 10.1.11.1, lease for 7 days. Let's go ahead and paste that in there. And let's look at our DHCP pools again. So I've got one for the WILC, even though we're probably not using this for anything. We're not, at this point, using this for anything. I've got one for AP VLAN 210, some APs there. I've got one for sales clients. They don't have a DNS server, but that's okay. We're not really going to send them out to the internet. I've got one for APs, my second range of APs in VLAN 211. And we don't really need two separate VLANs. I'm just demonstrating how we could have APs into or multiple different VLANs. And we're also going to need one, let's just go ahead and create it here, for our guest wireless LAN. So this will be network 10.5.5.0. I really wish I could say /24. Default router 10.5.5.1. DNS server, we don't even care about it. Let's say Google 8.8.8.8. Lease for 7 days. And we're good to go. So we've got all of our layer 3 SVI or switch virtual interfaces. We've got the layer 2 VLANs, and we've got the layer 3 DHCP pool set up to hand out IP addresses to our various AP1 and AP2 pool, our sales, our support, and our guest wireless LAN. So we'll save our router config, copy, run, start, or just WR for quick. So we've set up everything that we need to on our wireless LAN interfaces. Let's go ahead and see if anyone has gotten a DHCP address. Show IP DHCP binding. We do have people in the 10.1.10. Okay, and we can see the 01 here. If this looks a little strange for a MAC address, that's because it is. This is actually called a client identifier. 01 is indicating the type of medium that it's on, Ethernet, and then this is the MAC. So all of them will start with 01. This is the MAC address. If you wanted to shift the dotted decimal notation over, you could. We've got something on 10.1.11.2. Okay, so 2894 0 Foxtrot 2613 Echo Alpha. So let's do a show power. Let's do a show CDP neighbor to see. Well, we're actually not going to see those unless we do a detail. Let's say let's do show VLAN brief, and we see that we got port 11 and 12. So let's actually do a show CDP neighbor F0/11 detail. And we can see the MAC address here, or we should be able to see the MAC address somewhere. I'm not seeing it right now. Okay. Well, we'll take a look at the MAC address when we get into the wireless LAN controller interface. But show IP DHCP binding. We do see that we're handing out IP addresses in those two VLANs, VLAN 210 and VLAN 211. Notice that we have nothing in 10. We have a number of things in 10.1.1.1. We'll have to see what those are in a little bit. We have nothing in 10.10.10.10 or 10.20.20.0 or 10.5.5.0. So again, show IP interface brief, pipe to exclude unassigned. Those are our client, where our actual wireless clients are going to be. And we're going to fire up a laptop here and attach it to each of the different SSIDs, and we'll take a look at that. Okay, but it looks like our switch config is good. We've got our ports mapped properly. We've got access port where we need to. We've got trunk ports where we need to. We've got our wireless LAN controller connected. The wireless control system is actually running on my laptop in a virtualized environment, so it will actually be, it has a static IP, so we'll just be pulling it up there. It's time to go over to the wireless LAN controller interface.